My name is Shai Maskit, Director of Technical Marketing. Great to be here today. What I'm going to cover in the demo, I'm going to show database quality of service, okay, but also talk a bit about our quality of service in general, because this is a preview. This is the first time that we're showing it out to the public. It's not GA'd yet, but it's already, we have it with limited availability. So I want to talk a bit about quality of service and what it means to our customers, okay? The problem, I think, is pretty simple. The problem is simple because quality of service nowadays is complex, okay? So when you think about how a customer needs to implement quality of service on his array, it means that he has to start figuring out what type of dials and what type of knobs needs to be set, what type of IOPS, maximum, minimum, burst, and really understand the workload of each application, and then worry about stuff like over-provisioning of performance. And we set ourselves a target to come out with quality of service that really brings value to the customer, okay? So it'll really bring value to the customer if the customer doesn't find this feature as a burden. It'll find it something useful and easy to work with. So we say, okay, let's come up with some predefined policies. Okay, very, very simple. You have silver, you have gold, and that's about it. Okay, the only exception would be restricted policy, which means if you have 1,000 volumes and you have just one volume used by an application and it's hogging all the performance, you would rather restrict one volume group rather than bring up the priority for 999 different applications. Okay, so really coming with predefined policies, and of course we'll also allow for those customers who say, no, I want to control the number of kilobyte that are written to a specific volume. We'll allow that fine-tuning as well, but for most of our customers that we've tested this with, it received very good feedback as far as simplicity is concerned. The next thing is, quality of service is great, but how can we combine it with the value that Shahab presented before? As far as the entire IT stack, and also to give this quality of service somewhat of a differentiation in the market. And I think that when we combine it with the data that we get from the agents or from the application environment, or if it's the infrastructure environment, we can see specific workloads such as OLTP versus OLAP, okay? And it's not only Oracle, it can be SQL Server, DB2, whatever database. These characteristics of workloads are pretty common. And then we can close the gap between the storage and the database. Okay, most DBAs that we talk to, they find storage to be a mystery. Okay, they don't want to know storage. They're not interested. They just want their transactions to run fast. Okay, and with the storage people, they say, okay, how can I help my DBAs? How can I help my applications people to get what they need very easy? And the thing is that we can really adapt, okay, for customers that really want to control and configure and give, different quality of service during the week, like Monday to Friday, but then on the weekend give priority for batch processing. They can run over the weekend under a limited time window. That is also something that we can help customers really achieve very easily, to modify and to do things dynamically. So just a glimpse at the health shield that we were talking about. This is how it looks like as far as the reports that we use. I think the health shield, with our support team giving them these tools of the health shield, really allowed them to reach a higher level of support to our customers. Okay, our customers really value our service, mostly because we have the tools to give that best quality of service for them. So I think we can contribute attribute one of the reasons that we reached over 5 nines of availability to the Health Shield platform. Okay. Okay, so now just a quick description of the demo environment, just so you can get your bearings. We have a single K block okay, with 2 SSD shelves. It was scaled up to 2 SSD shelves. On it, we have several volume groups. We have an Oracle environment, which is running OLTP workload, production workload, okay? And we have a snapshot of that environment, and we have just attached another Oracle VM to that environment. So it's very, very cost efficient, and the analytics or the online analytics processing is done on a very fresh copy of data of the production. We also have some Windows virtual machines just running synthetic workload VDbench, okay? And throughout the demo, we'll also see the K2, we'll also see the Health Shield, and we'll also log into one of the shells of the Oracle just to see some of the output of the run. We have the Oracle running continuous workload, both the OLTP and OLAP in a loop, just so we can see the effect of the system. Okay, so this is the K2 GUI, okay? What you can see that it's currently running as far as performance over gigabyte per second of throughput. It's running over 120,000 IOPS, and overall average latency is just above 0.7 milliseconds, okay? I just want to focus for a second on the middle tile, which is the data reduction tile. You see data reduction is 4.5 to 1, okay? Mostly from the databases that we host on the Kaminario. So this data reduction is stemmed from the compression mostly. There's hardly any deduplication with the Oracle databases. Okay, next we'll go to the Health Shield. So as mentioned before, this is a SaaS-based, cloud-based solution. So it's very, very scalable as far as matching the demand from the hundreds of customers and systems that are installed. And all of them are sending in a frequency of seconds information and thousands of data points to this system. At the moment, what we see here myself logged in as if I were a customer. I think there was a question here before if several arrays can be aggregated to a single view. You say yes, it is possible. Theoretically, if I had more arrays under my credentials, I could add them. A fair point is to say what we can offer our partners, okay, our channels. Our channels like to be close to our customers, which are joint customers, and really understand what they're going through and how they can also be in touch with them. So we are planning to allow this type, or maybe a more restricted view. It depends what the customer will allow the channel to see. Also to have access per customers or per sets of customers to our channels. Okay, so let me just make this bigger and explain what we're seeing here. What we're seeing here is a dashboard of all the applications with their performance and respective quality of service that is currently installed. So we have those Windows applications, the VDbench running synthetic workloads. They already have gold policy, so they enjoy a lot of the system resources of the array. Oracle Perf, that is my production database. I can see I have an exclamation mark. We'll talk about it in a second. But the same application has 2 different quality of service. For the archive, which is mostly meant for snapshots of the Oracle Silver, but the more interesting is gold for the Aura data. And I see here that I have an alert, okay? So let me click the alert, and it tells me that this application, it might run faster if I change the quality of service properties for it. If I see more details, well, the top part is not really interesting. It's just, timestamps and different attributes of this alert. What's more interesting is this part. So this specific volume group of Aura data, which has the data of the database, and the redo log, we've noticed that it's running over 0.9 millisecond. So one would assume 0.9 millisecond, that's great latency, right? But we have thousands of data points for every second, so we have a lot of history for this specific array. We know for certain that this array, or this specific volume group, has enjoyed much better latency in the past, okay? So this is information that we decided, just looking at the history of the K2. But the more interesting part and the novelty is joining this information from the K2 from other pieces of the stack. So from the automated workload repository of Oracle, the AWR, we see two interesting things. The first one is pretty trivial, that the transactions have 1.1 millisecond latency or above, okay? Which is this, the overhead of the Fibre channel and the application stack itself from 0.9 to 1.1. More interestingly is that how we've decided, the heuristics that we've decided that we can make an impact here. So from the top 5 foreground events, okay, we recognize that they are I/O bound, which means they spend more than 80% of their time waiting for I/O. So this is like the best way to recognize that improving the latency for that type of transactions will allow us to achieve better results, a better service for that application. Okay? So
how much of the data are you having to manually configure to match up host and array? And how much is automated and can just self-discover?
So it's a good question, because when we set up the agent, okay, we do ask the customer to have access to the AWR, okay? If the customer doesn't have license to AWR, we can have tune or do manual things, but we'll achieve the same resolution of information. And then we just have to know the mapping between what is mounted on the virtual machine and the volumes themselves. So using just, matching between SCSI serial numbers, inquiring the SCSI device that you see in the Oracle and matching it to what we know in the Kaminario, that's pretty automated.
Okay, and the reason I was asking that really is, if you've got an environment where people are creating and destroying a lot of VMs and there's a lot of churn, the last thing you want to do is have to manually go in and deploying and mapping and trying to keep on top of that, because it's a lot of work. And then you lose the value of what your platform is.
So the majority, I would say, is automated. We allow customers, obviously, we can't get everything right. So if the customer is saying, well, specifically these two applications are separate and not just one, I want to be able to see them in a different view, so we'll allow that, obviously. So we'll do our first analysis, automated analysis, and then allow the customers to fine-tune if they want. Okay, so what I'm going to do now, I realize that I want to make a change. Okay, this is the recommendation telling me if I change the quality of service, I'll get better results. So the thing is, I have business critical applications running. One of them is the production, and the second one is the Oracle online analytics. Okay, I didn't give it high quality of service. It's silver. Okay, it's the Oracle Snap. But it's still very important, and I want to make sure that none of the changes that I make wouldn't impact my business. So we allow a comparison. I'm going to demonstrate now comparison between two volume groups. So what do we see here? We see here real-time monitoring of those two specific volume groups, the Aura Data VG and Aura Data VG Snap. Just to give you the whereabouts, the top bar, the purple is throughput. The green one is the IOPS, and then you have the blue, which is the latency. If you can see, I don't know, it's pretty small, but you can see the breakdown of the latency, which is another unique thing that we offer. We have the inner latency, which is how we measure the latency internally, but we also know what the fiber overhead, okay? We can measure that. And then we have the total. The reason why some of our customers have very elaborate and sophisticated fiber channel topologies, so you can go through a few switches until you actually from the host to the array, but the internal latency is what we can control. Actually.
How are you measuring the fiber channel latency?
We have the AX and the between the host. The read and the write are accompanied by a lot of SCSI messages as well, so we were able to track those as well. Okay, so what I'm going to see here, this is my recommendation. Okay, change quality of service policy to application aware OLTP. Okay, what does that mean? What did we recognize that we came up with this recommendation? We recognize a pattern. Okay, a pattern of small IOs. Okay, so it's already in gold, right? So it's already getting all the resources, but what we recognize is for this specific pattern, if we can give priority to small blocks, okay, which is the, when you look at an OLTP workload, this is pretty much what you'll see, small updates and reads. So we'll get better latency, okay? And I think it's a good place to say that the K2 array is very consistent and predictable with latency, okay? So this is why we're able also to do all the heuristics, but also to predict what would be the impact of such a change. So I'm going to hit predict. Okay, what do we see here, and what was my first objective here? I wanted to see that I'll get, okay, and this is already something that the Health Shield already analyzed, and that's like an insight or a good insight that we found, okay, otherwise we wouldn't have made that recommendation. But what we wanted to see, what would be the impact on the OLAP, or the analytics running on the Oracle. So we see here before it was, 1.08 milliseconds, and now it went up just 0.05 milliseconds, okay? Is this something that I'm able to tolerate as a business, to have that kind of impact? I guess so, okay? Because my production or my main business comes from the OLTP. Maybe on the weekend, not that won't apply, but on the weekend we can change dynamically change the quality of service. Okay, so with this prediction, I want to go back to the Kaminario K2. I'm going to go to quality of service under volumes, and I'm going to change the quality of service for the Aura Data VG. That was my recommendation. And like Shachar said before, at the moment, we don't want to impose on the customer any decision. We let the customer make the change themselves. In the future, we might automate it and let control from one place, but security-wise, all of our customers said, let us do the change. You can recommend, that's fine, we'll make the change. So with that, I'm going to change it to the OLTP, and I'm going to hit confirm. Now, minding you, this is a running workload.
How many application-aware QoSs do you have?
Okay, so
OLTP?
Yeah, OLTP. We have also OLAP. Okay, we decided to focus mainly because of the 2015 results that most of our customers are SaaS-based. So we decided we'll target databases at the beginning. So OLTP, OLAP, that would be the immediate suspects. But we are planning to introduce more predefined quality of service policies.
And of course, as we have collect more and more data from many customers, we learn many interesting things. So even customers that will not use these capabilities will gain the benefits of new, interesting, and efficient quality of service policies.
Okay, so what I'm going to do, I'm going to set up the analysis of the K2 itself to be able to track the changes. But it will take several minutes. So in the meantime, I'm going to pop up. I hope it's not too big. Is it too big? Oh, it's okay. So this I'm just tailing on the Oracle server. This is just your simple party shell that tells me how long the OLTP workload has been taking so far. So because it's running in a loop, you can see it's pretty consistent, roughly 217, 213 seconds. Okay, and we'll wait for it to pop up with that it has ended another cycle, so we can go back and track our changes. So in the meantime, I'll take questions. It's a good time might take a minute or so. So any questions so far?
So does the agent that runs on the host, is it application specific, like VMware, Oracle, KVM?
Yes.
It is?
Yeah. So we're working both with our technical partners to come up with the right sort of agent that will fit their environment with as little friction as possible on one hand. On the other hand, we don't want to rely too much just on the agents. So if the customer will come and say, hey, I don't want to install agents, we can do that as well. And we'll just let them know, okay, so maybe you tell us what type of application is it. And then if you choose it's an Oracle, we'll tell you what kind of policies we can suggest that will make your life easier and give better quality of service to your users.
First cycle.
First cycle ended. Okay, so it's probably mid-cycle, 188 seconds. So you can already see we've reduced it. So I'm just going to click here to fast forward the analysis and to see how it comes in. Again, apologies for the lag. This is in Israel, the Israeli lab.
This analysis is historical based on this workload that's been running here for a period of time.
Yes.
What components cross-customer are being factored into those analytics, if any?
Okay, so this is actually on the array itself. As mentioned before, this is pretty lean analysis, not something very sophisticated because we don't want to overburden the controllers that are servicing IOs. We would, rather have the back office, the health shield, run that. But this is just the immediate place where you see real-time performance as it changes. Okay. So here we don't have any customer cross analysis being done, information being done.
That's the plan, to be able to take cross-customer information to further define these.
Yes, but not on this platform, rather on the Health Shield platform, which is SaaS-based, and we can, it's elastic, so we can add more cores if we want to do more complicated calculations. But here we just want to keep it simple, so we have an analysis back 3 months of the data only on this system.
Is that on the array itself?
Yes, this is on the array itself.
This is the GUI of the array.
Yeah, but is it like a separate management server for that, or is it just
integrated into the array? Just log into the management IP, the same IP which we use for RESTful API, CLI, etc. Okay. So what do we see here? This, as you can see, very consistent. These were the previous runs, and you can see the latency was practically the same bars that we've seen on the Health Shield, but local we just see one volume group at the moment. So we see the latency is just above 1 millisecond, and this is where we can see where the change took place. Okay, roughly here, where we go from 1 millisecond latency to 0.7 millisecond latency for this application, and you can see that the Oracle was looking for more ways to push more IOPS, because you can see that the IOPS are going up. Okay, from 20,000 IOPS to, 25,000 IOPS, okay? And the latency is just going down. And if I switch back to, still another cycle is running, but when the second cycle will finish, we'll notice, also the reduction in the runtime. So we see less latency, roughly 20%, 20 to 30%. We see better IOPS as a result of improving the latency. And it's math, but you see that the runtime has been shortened as well because you have more IOPS with shorter.
The color scheme there, the darker color is like and the IOPS is writes versus reads.
So yes, darker color is writes and lighter color is reads. And
same thing on the top, which is the throughput.
Yeah, exactly. So here you see that we are 25% write, 75%, 74%. Read. You see also the block sizes, by the way. You see that 80% of the block sizes is typical for the OLTP application, so it's 8 kilobyte and less. Okay, and also here we can see what that 96% of the IOPS are gained from the 8 kilobyte block sizes.
So what happens if there's a disk failure?
Okay.
If the array is in a degraded state, will QoS kick in and guarantee performance on gold?
So that's a good question. To simplify things, we see quality of service as a pool of resources that a system can deliver. Okay, and we divide this pool to silver, to gold, and when we have application aware, it's just on top of the gold. Okay, so let's say I lose a drive. Actually, when losing a drive, you don't lose performance. Okay, even when you lose 2 drives, you don't really lose performance. You lose performance, let's say, when you lose a controller. Okay, so when you lose a controller, now the system resources just shrunk. Okay, depending how many controllers you have in your array, but it went down. So now there's still a pool of resources that will be redistributed. They'll the same percentages, but each component or each application will get just less. Okay, so it's still divided the same way.
Okay.
Yeah, it seems like the performance throughput increased considerably at first, but then it's kind of back to where it was before. Over time, is that an artifact of the workload that's going?
So yes, because the OLTP has some updates in it. So what happens that at the beginning it makes a lot of updates, and then you see the spike in the bandwidth because a good way to see it is how at the beginning the amount of block sizes between 8 to 64 kilobytes are larger. That's why you have roughly the same number of IOPS. Tell you what I'll do. I'll just skip here because I got a notification. Then it went down again, right? So 180 is the final runtime. Down, pretty good. It's just half a minute. Yep. Okay. So yeah. So this is a typical run. Like you said, you see a spike at the beginning. So you see less IOPS at the beginning, but more bandwidth. But you do see that the block sizes are more, you see more bigger blocks. You even see 8% of the block sizes come from 64 kilobytes to even half a megabyte. So that's the beginning when you start accessing the tables and doing more writes even, and you also access also the data and also the redo log of the database.
Can you see the impact of this on other workloads that aren't checked? So they.
Yep. Let's look at the Aura Data VG Snap, which is the one that we wanted to see how it will be impacted. And this is just the lag of the hotel's Wi-Fi. So, okay, I'll even remove the Aura Data. Okay, just so you can see how the OLAP or the online analytics looks like. Mind you, this is a snapshot. Doesn't really consume capacity, but we treat it as any other volume. Okay, so we track performance and any other metric. Okay, so this is how it was running before. And this is how it's running now. You don't see a lot of a difference, right? Because we predicted that. We predicted that the impact on the OLAP, which is also business critical, but not as much, it will be negligible. We said it's going to go up to 1.15, but not even, right? It's pretty much stayed the same. So I guess we did pretty good there.
What about the workload that was doing 100K IOPS? It wasn't the Oracle one. I don't know which one it was.
Yeah, it was. It's general. It's the Windows application. I'll add it as well, just so you can see.
Maybe we'll put everything together and just see.
Yeah. Actually, now, pretty much these three were running all the workload. The rest is just inactive Oracle instances that we have on this system. Yeah. So I've added. So now you see that the IOPS are like. Again, 90% read, 10% write. About just over 100,000 IOPS, reaches 120,000 IOPS.
So basically we see similar performance, but we share the resources in a much more optimized way for the customer application needs.
And the optimization was to operate faster for small blocks, or
yes.
Some sort of a small block optimization?
Because both, I'm reminding you that this Windows application also had gold, okay, and we wanted that was hogging a lot of the application, getting a lot of the resources of the array, which is okay, but we wanted more priority for those small blocks. So you can achieve that only if you really identify the workload that you're running.
And essentially, it's metadata operations got higher priority or something like that? Or?
Well, Oracle metadata operations got higher priority, and the redo log got higher priority.
Okay.
And internally, it's different queues to make sure that the smaller I/O gets better priority.
Right.
For this specific volume that we identified.
Yep. Okay. So just to conclude, what we've seen here is how we take quality of service as a feature. We introduce it as something simple, something that the customer can really use without starting to what should I do? How should I configure it? I don't want to use it, it's too complicated. But we took it up a notch and not only simplified the problem, and we gave a very simple and easy to use feature, but we also, the novelty here is to match it with the application layer, okay? So to give much better service, quality of service for the application.
But it's on a volume level, right?
Sorry?
It's on a volume level.
On the volume level, yes. We can do volume level, volume group level, and also application level. So it's pretty much a hierarchy. So like an application might have several volume groups have several volumes. So you can just fine tune it as how you wish to.